Hello friends, welcome to Suresh Agarwal's Mathematics Shortcuts. So a special video for my class 10th students who are appearing in the board exams, and this is the chapter on some applications of trigonometry, otherwise known as heights and distances. What is special about the video? We are going to take up some so-called simple problems, but they are also like 5-mark questions. Simple in the sense that they involve lesser calculations and lesser complexity in terms of understanding of the question. So these are based on two right angled triangles. So in every figure you will be having two right angled triangles. So without wasting any time, let's get into one of the important problems. Here we have a question where the shadow of a tower standing on a level ground is found to be 40 meters longer when the sun's altitude is 30 degree than when it was 60 degree. So the comparison of the shadow at two different times in a day is given, 30 degree and 60 degree. So suppose this is the tower, vertical tower, and this is the level ground. So when the sun's altitude is 60 degree, so this angle is 60 degree, then the shadow is, say, if PQ is the tower of height h, then QR is the length of the shadow. So let's check whether we are given QR or not, and this is perpendicular. Likewise, the altitude of the sun now changes to 30 degree. So this angle now becomes 30 degree and the length of shadow is from Q to P. So this is the length of the shadow now when the sun's altitude is 30 degree. The shadow is 40 meters longer. That means this RT is given as 40 meters. The change in the length of the shadow when the angle changes from 60 degree to 30 degree. Now using this figure we need to find the height of the tower. So I have told you in my previous video that you got to write whatever you are making in the figure, you have to write what is PQ, what does it represent? It represents the tower of height h. What is QR? QR is assumed as x meters and that is the length of the shadow when the sun's elevation is 60 degree. Likewise, QT is the length of the shadow when the sun's altitude is 30 degree. So all those things have to be written in statements here, and that will help you in getting full marks in the question. Right. So I'll write only the assumption part. I have assumed QR is equal to x meters, and now I am going to use, we have PQ, right? PQ also as the height of the tower, which is h meters. Now I am going to use the two right angle triangles in this figure to get to my answer. The first one is PQR. So in triangle PQR, we have application of tan theta, that is tan 60 degree, perpendicular h upon base x. So you can see tan 60 perpendicular upon base. Likewise in the triangle PQT. So we have the other triangle in triangle PQT. So angle changes to 30 degree now and the height remains the same, but the length of the shadow is now x plus 40. So we have to take x plus 40 in the denominator here. Now that is important. Some students write 40 and the question goes wrong there itself. Now using these two equations we have to find what is the height of the tower. So let's put the values of tan 60 and tan 30. Tan 60 is root 3 h upon x. Tan 30 is 1 by root 3 h upon x plus 40. So if you cross multiply here you will get h is equal to root 3x, and if you cross multiply here you will get root 3h is equal to x plus 40. Now what we need to eliminate is important. See, we don't want the x, right? Because he is not asking us the length of the shadow at 60 degree angle. He is asking us the height of the tower. So let's eliminate x. From here x is root 3h minus 40, and if you put this here you will get h equal to root 3 times root 3h minus 40, and that gives you h is equal to 3h minus 40 root 3. So 3h minus h is 2h equal to 40 root 3. and so the value of h is 20 root 3 meters. So the height of the tower is 20 root 3 meters. Obviously you can now convert it into decimals by putting root 3 as 1.73. So this is 17.3 times 2, which is 34.6 meters, which is the answer for this particular question. So this is all algebra, right? How to eliminate one of the variables and get the value of the other variable. So this is how the question on the length of shadow of a tower works. Likewise, let's have another question where we have two objects. One is the tower. So there is a tower, and the angle of elevation of the top of a building from the foot of the tower is 30 degrees. So we have a building also here, and this is the horizontal distance between the two. So we should know what we have labeled. Now this AB is the building. So I'll write here AB is the building, and let's assume this as CD. So CD is the tower. Right. Now the angle of elevation of the top of building, that is A, from the foot of tower is D. So from here, if you measure the angle of elevation like this angle is given as 30 degree. And let's see the other angle of elevation of the top of tower, that is C, from the foot of building, that is B. So from here to here the elevation is 60 degrees. So let's join this also like this, and this angle is 60 degree. Now this is the figure for the question, and what else is given if the tower is 50 meters high. So this height is given as 50 meters. So we have marked everything in the figure itself, and we need to find the height of the building H. Now to find this height H, I need to use the triangle ABD, and for that I need to have one of the sides of ABD, but no side is known. So for that I will be using the other triangle CDB. So let's assume this is the common side X between the two triangles. So let's assume that BD is X meters, and now I can apply tan and get my answer. So in triangle CDB, tan, now look at the angle here, it is 60 degree, equals perpendicular is 50 upon base is X, see, and so I can get the value of X from here. Root 3 is the value of tan 60, so 50 upon X. So if you cross multiply, you will get 50 upon root 3 as the value of X. So I don't want to convert that into a decimal, because he has not asked us to find this distance. He is asking us to find the height of the building H. So let's take the other triangle. So in triangle ABD, always take a right angle triangle, because you have to apply trigonometric functions. Tan 30, here we get tan 30, perpendicular upon base. Perpendicular is H, base is X. So H upon X. Now tan 30 is 1 by root 3 is equal to H upon X. Now if you cross multiply, X will be root 3H. And what is the value of X? It is 50 upon root 3. So I can put 50 upon root 3 here is equal to root 3H. That will give me the value of the height of building. So if you cross multiply, you get 3H is equal to 50, thereby giving you the value of H as 50 by 3, which is 16.67 meters. That is the height of the building. So all calculations after you apply the trigonometric ratios, right? So this is how you solve the question of two vertical objects. The next question is based on another question where the figure is really important, and if you get the correct figure, I think more often than not the answer will be correct. The angle of elevation of the top of a vertical tower, so there is a tower, from a point on the ground is 60 degree. Okay, so we have a tower, and this is the ground level, and here is the point P from where we are making the observation, and the top of the tower is an elevation of 60 degree like this. Now what is the next statement? From another point 10 meter vertically above the first. So the first point is P, right? So 10 meter above P like this. Here you have another point Q, and this is 10 meters. and from Q the angle of elevation is 45 degrees. So now if you measure the elevation like this and draw the horizontal, you will have the angle of elevation as 45 degrees. So see the figure, it is altogether a different figure here. So let's name it as A, B, C, right? And we need to find the height of the tower. So this height is to be found out. So let's assume that this height is H. Again, you have to write everything. What is AC, what is PQ, and what are the angles given here. And now, if you see the figure here, the side BC, this side is actually equal to PQ, right? And that is 10 meters. So this is also 10 meters. And so what will be AB? AB will be AC minus BC, and AC minus BC comes out to be H minus 10 meters. So this is H minus 10 meters, right? And I told you already that whenever you have a question of heights and distance, the horizontal distance, this has to be assumed as X, so that this also becomes X. And now I can apply tan in the two triangles and get the height of the tower. So let's take the triangle ACP first. In triangle ACP, so tan 60 degree, perpendicular H, base X, you can check, this is H and this is X. So tan 60 is root 3, so H upon X, cross multiply, root 3x is equal to H. We will come back to this later. Now let's have the other triangle ABQ. In triangle ABQ, tan 45, right? So tan 45 is equal to perpendicular upon base. Perpendicular is H minus 10 upon base is again X. You can check. Tan 45 happens to be 1, so H minus 10 upon X. So X is H minus 10. So I know the value of X here, so I can put this value here and get the value of H. So elimination, that's what is going to work. So what am I going to do? Root 3 times X. X is H minus 10 equals H. So I substituted the value of X from here to here. Now open the bracket, root 3H minus 10 root 3 equal to H. So you get root 3 minus 1 into H is equal to 10 root 3, and thereby giving you the height of tower as 10 root 3 upon root 3 minus 1. Now this is the answer, you can leave it here, but if you find time in the exam, if you have time left in the exam, like last 10 minutes, you can come back and put the value of root 3 as 1.73 and get the answer, or you can rationalize this and then convert it into a simpler form. Let's do one thing, you can find the answer in the decimal form, and I leave it for you as a do it yourself question. Do post your comments here that what is the value you got. Okay, let's see the final question for this video. An airplane when 3000 meters high passes vertically above another airplane at an instant when the angle of elevation of the airplanes from the same point on the ground are 60 and 45. So what does the question say? Here is the ground level. Okay, we have one aeroplane here and one aeroplane vertically above this here. So these are the two aeroplanes. This is 90 degrees. So positions of aeroplane are A and B. So the upper aeroplane at B is 3000 meters high. So this height is 3000 meters. This height, right? Now the angle of elevation from this point, say P on the ground, for this aeroplane is 45 degree, and for this aeroplane it is 60 degree. So that is mentioned in the question, and we need to find the vertical distance between the aeroplanes. That means AB, the distance AB. Let's assume that the vertical distance is H. Now there are so many things which we don't know in this figure. One is the horizontal. So I told you we always have to assume the horizontal as X, and we don't know AQ also. So what will be AQ in the figure? AQ is actually BQ minus AB. BQ minus AB. So BQ is 3000 minus AB is H, and so 3000 minus H. This is what is required to be used in the figure. Now I can use the two triangles. So I am using the bigger triangle first, BQP. So in triangle BQP, tan of the larger angle, that is 60 degree, equals perpendicular upon base. Perpendicular is 3000, base is x. So 3000 upon x. And you can see if I put root 3 here, I will get the value of x directly. So x is 3000 upon root 3, which I can rationalize by root 3 and get 3000 times, right? So this is 1000 root 3. So I get the value of x as 1000 root 3 meters, but I don't want x, I need h, the distance between the aeroplanes. So I will use the other triangle now, AQP. So in triangle AQP, tan 45 now, this time the angle is 45, perpendicular 3000 minus h, base x. So 3000 minus h and base x. Now tan 45 is 1, 3000 minus h upon x. So if you cross multiply, x is 3000 minus h, and now x is 1000 root 3. So I can put here 1000 root 3 and then equals 3000 minus h. So h is 3000 minus 1000 times root 3, which is 1.732. So h is 3000 minus 1732, which is 1268 meters, and that is the vertical distance between the two aeroplanes in the question. So you can see lot of calculations involved there, but the questions are not difficult because they don't have like very in-depth concepts involved. So if you are able to generate the figure correctly from the given statements and apply tan in the two right angle triangles, you will get the answer correctly. So friends, we have more videos coming up for this chapter because it involves some complex questions also, long answer questions, 5-mark questions. So look for that part. Till then, share this video, subscribe the channel and click the bell shaped icon for getting all the notifications of the channel. Thanks for watching this and all the best for your practice.